back in May, one of the servers that I was working on was compromised by a fileless cryptocurrency mining malware. And in that case, the attack vector was a Postgres server that was left exposed through lack of a firewall. In another case, 2 years ago when my brother and I sold our business, one of the prospective buyers hacked into our database and corrupted a bunch of the entries. And in yet another case, when I was working in Germany for a blockchain startup, one of the developers insisted on using root, and let's just say he removed his French language pack. So it's fair to say that I've had my fair share of hacks or compromises or problems. But would you trust a captain who hasn't sunk his ship? You probably would. Nevertheless, in this tutorial, I'm going to show you how to harden your Arch system. I've got a fresh install of Arch on this ThinkPad T480, so come along, I'm going to teach you how you can tighten up your security. Let's go. When we first log into an Arch system, we are the root user, and we don't want to be the root user because we want to adhere to the principle of least required privilege. So we want to create a user for our day-to-day, and then when required, we want to escalate privileges with the Sudo utility to have root privileges. And then when we don't need it, we don't need to escalate. So we're going to first create a user. And the way that we do this is with user add, and we're going to give this user a home directory, and the user's name is going to be Boris. Now we've created this user Boris, and we first want to see which groups that Boris has been assigned to. And by default, Boris will only be assigned to his own private group. We can have a look at that with groups and then Boris. And we can see here we've just got Boris, he belongs to his own group. Now we want to give Boris access to two groups. One is going to be wheel, and wheel refers to the big wheel, or who has the power. So when we use the sudo tool to escalate privileges and act as root, we need to give Boris access, or we need to add Boris to a certain group called wheel. We also, for the purpose of this tutorial, because you'll see it in a lot of systems, I'm going to add Boris to the general users group. So the way that we do this is we actually call it append. We say user mod -a for append because we don't want to overwrite the existing groups that Boris has been added to. And we want to say wheel and also users, as I mentioned, and then we want to add this to Boris. Okay, so now if we say groups Boris, we can see that Boris is a member of these groups. We want to give Boris a password. So the way that we're going to do that is with passwd and then Boris. Okay, and we're almost ready to log in as Boris instead of root. The last thing that we need to do is we need to use the vi sudo. And this is a tool which allows us to edit the sudoers file. Now, the sudoers file is the configuration for our sudoers or our super doers, super users. And if you haven't installed sudo yet, you can do that simply with Pacman -s and then sudo. So go ahead and do that. So we're going to say vi sudo. And then here we want to go to the bottom of the file. And we want to make sure that this line here is uncommented. And as we can see from the comment here, it says allows all members of group wheel to execute any command. So we've added Boris to the group wheel. Now, if you see a little bit down here, this is the same thing, but there's no password requirement. We want to have a password requirement. So when our user is temporarily using root privileges, or we are escalating privileges, we want to require a password. However, we are allowing Boris to act as root or temporarily be escalated to those privileges. So let's write and quit. And now we're ready to log in as Boris. So let's say su and then Boris. Okay, so the first thing that I'm going to do is I'm going to change into Boris's home directory. We created that, if you recall. If we say ls and then home, and we can see in here we've got Boris and also rad, which was a pre-existing user that I have on this machine. So I'm going to say cd and then tilde, which is the same thing as saying home. This is the same thing as saying home Boris. Okay, and now I'm going to clear the screen. We are presently in Boris's home directory. We can verify that with the pwd command. It's really important that you understand how permissions work and how users work and how these work with files in Linux. So in this next example, it's a bit contrived, but Boris is going to create a file called secret, and I can show you how other users can or cannot use that and also how the permissions determine who can read what. So let's get into that. Now, Boris wants to store a secret phrase or password. We're going to call it the secret. So let's create a file and we're going to say this is a secret. And we're going to put this into secrets.txt. Now let's have a look in that file to make sure that it went in. And we can see that the secret phrase is in the file. However, if we say ls-l secret, then we can see here that the owner, Boris, has read and write privileges, but not execute. This is not an executable script, but also groups and also other have read access. So everyone in this system could conceivably access or view this file. We can see that the owner there is Boris, and that the group that this belongs to is Boris. And finally, we can see when the file was created and the name of the file. So we want to prevent other users from seeing what's in the contents of the file. So what we're going to do is we're going to use the symbolic chmod command. They're more human readable, and the basic concept is that we can give read, write, or execute permissions on a file. So let's go ahead and we're going to remove all of them. How do we do that? We say chmod and then we say all equal to nothing, and we're going to reference the file. Now if we have a look at that same command to ls, we can see that although this still belongs to Boris and the Boris private group, no one actually has access to it. So if we went to have a look at it, we can see secret, okay, permission denied. Okay, so I only want Boris to be able to see it. Let's go and give him read access. So we're going to say chmod u for owner plus r, and we're going to reference secrets. Now let's go and cat that file, or first let's see what's in the file. We can see the permissions rather. First let's see the permissions, and we can see that there is read access only for the owner of this file. So let's have a look in it. Okay, and we can see that this is a secret. Just to demonstrate that others on the system can't see his file, I'm going to put it into a directory that everyone has access to on the system. So in Linux, we know that we have all of these directories, and the one that I'm going to use is tmp. So I'm going to move this secret and I'm going to put it into tmp, and it'll be called secret. Next, I'm going to log in as another user, and we're going to demonstrate that we can't see that file or see the content of that file. Okay, so I'm logged in as another user, rad, and I'm in the tmp directory or temp directory, and I want to see what are the contents of Boris's file. So I'm going to say cat, and then I'm going to say secret, and I can see that I get permissions denied. If I have a look at that file, we can see that it belongs to Boris and only Boris is able to read it. However, there are two users who are able to amend permissions on a file. One is the owner and the other one is, in fact, the root user. So my user rad that I'm presently logged in as is also a member of the sudo group. So I can say sudo and then cat and then secret. And we can see that I can get into that file and I can see the content of that file. So you can see that I've escalated privileges, and even though Boris is the only one with read access, I can actually, as the root, go and have a look at the contents of that file. Okay, but what if we don't want to escalate to the root user? Well, we might want to either give rad direct read access or as a group. So therefore, what we're going to do is we're going to say, I'm going to log back in as Boris. Now, both rad and Boris belong to the users group. So therefore, I'm going to change the group that this file belongs to users, and I'm also going to allow group members of users to have read access to this secret. So let's go ahead and do that. So we're going to say chgrp users and then secrets, and now if we have a look at the file, we can see that owner is Boris. However, the users group is the group associated with this file. Rad is a member of the users group. However, the users group still doesn't have read access. So we say chmod and then group plus r for read and then secret. And if we go and have a look in there, we can see that the owner and now the group have access. So I'm logged back in as rad, and now I'm in the temp directory. Have a look at groups, rad. We can see that rad belongs to users and also wheel, and therefore I'm going to say cat secret, and we can see that Because Rad is a member of users, he is able to reveal the passphrase. Of course, if we were to add the others, then everyone in the system is going to be able to read it, assuming that it's in a directory that they also can access. For example, Rad cannot access the Boris home directory without using sudo, and therefore that's why I put it in temp to demonstrate. So we saw that the sudo escalation to root privileges can be detrimental to a user like Boris who wants to protect certain information. So now you can imagine that if a malicious actor got root access to your machine, they can do anything that they want. In this next step, I'm going to be actually locking the root user's password, which means that they cannot actually log in, they can't SSH in, and we can't actually even switch user into root. Before you do this, it's very important that you have a sudoers file and you have sudoer users, because once this is done, you will no longer be able to use root directly. And so you need to consider that at the end of the day, security is all a balance between usability and protecting yourself. So just keep in mind that this is something that I do, and it just means that every time I want to escalate privileges to what would be root, I use sudo, I don't go in directly as root. So the way that we do this is we are going to say sudo password l root. So this locks the password. I'm going to say enter my password. So I want to demonstrate what this is done by locking the root user's password. So I'm going to say sudo nvim, which is my editor, etc, and then shadow. And we can see in here that root has this prefixed bang in front of it. And what this does is it tells the system to make password-based logins impossible for that user. So specifically for root, we can no longer use the password access. If you want to re-enable the user login for root, then you can simply say sudo password u root. In May, one of my clients spun up a server and neglected to add a firewall, which is a pretty basic step, but you know, these things do happen. And a malicious actor used the attack vector of a Postgres database to gain access to the machine and was ultimately successful in running some fileless cryptocurrency mining on the system. Now, it was particularly difficult to conduct forensic analysis or to understand what was happening because of the fileless nature of it. And this really could have all been avoided with the use of a basic firewall. So the one that we're going to be implementing is called UFW. We're going to install that with sudo pacman -s UFW. So go ahead and do that. Okay, once you've installed it, you just need to run sudo UFW enable. Now, we need to set some rules. So I'm going to say that we're going to allow all outgoing traffic. We're more concerned with what's coming in. So sudo UFW default allow outgoing. Okay, and then we're going to say deny, and we're going to deny all incoming. So all traffic which is incoming is going to be denied. Now, in my case, I want to have remote access to my machine. If you don't want to have remote access, then you don't need to set up SSH. Now, by default, SSH is on port 22. And one security measure that you could take is to put it on another port that people don't expect. However, in my case, I'm just going to go ahead. I'm going to allow SSH. And the way that we do that is with sudo and then UFW allow SSH. Okay, so now we can just check the status here with sudo UFW status and then verbose. And we can see that we have a bunch of rules here. So by default, deny incoming, allow outgoing, and then you can see that there's one rule which is allow in on port 22, which is the SSH port by default. Now, if you were running, say, a server and you wanted to give access to that specific server, the way that you would do that, you could say something like sudo and then UFW allow, and then say it's running on port 3000, then you could run this command. Now, in my case, I'm not, so I'm not going to run that command. However, this is a good segue into hardening for SSH. If you're going to use SSH, there's a few steps that you can take in order to make it more secure. One of the first steps that you can take is to prevent password access to your machine. So what I'm going to do is I'm going to copy in the keys. I'm going to generate some keys, and then I'm going to copy in those keys, and then I'm going to prevent password access to the machine for SSH. So let's go back to the other machine. So I am logged in on my other machine, and I'm going to generate some keys. I actually already have them generated, but just to show you how it's done. So the command is SSH keygen, and then I'm going to pass the type, which is an ED25519, and then C my email. So, okay, run that command and that will generate your keys. After you've done that, you can now copy them into your server. So for me, I'm going to run this command SSH copy ID and Boris, who is my user, and then the IP address of the target machine. You can obtain that by using the command IP addr show on the target machine. Okay, so the keys have been added. So let's SSH into the target machine. Okay, and so that's worked. We can see that we are now on the target machine and we weren't prompted for a password. There's still a few more things that we need to do though. The first thing that we can do is disable password authentication. And then there's a few other options that I'm going to take you through. So let's go ahead and we're going to edit the SSHD config. So the way that we do that is with sudo and then nvim, which is my editor, etc ssh sshd and config. Now in here, we're going to look for password authentication. And here I'm going to say password authentication and I'm going to set it to no. So we're no longer going to be allowing password authentication. Next, we're going to disable root login. So we're going to search for permit root login. And here I'm just going to say no. Finally, I'm going to change one more, which is PAM. And I'm going to say use PAM is no. Now, if you were using multi-factor authentication, you could enable this. However, we're not. So for the case here, we're simply going to disable it. So I'm going to now close it. And now I just need to restart the SSHD service. We can do that with sudo sbctl restart SSHD. And I made a typo. Okay, an important part of security on your Arch system is just keeping everything up to date. So obviously the package manager is Pacman, and you can always access the manuals with Pacman and peruse this. Now, importantly, we want to always keep our system up to date. We can do that with Pacman syu, and that will update that. So sudo and 2 bangs indicates you want to run the last line, but here I'm going to say sudo and update. Let's just run through a few really key Pacman commands. For example, we can have a look at all the packages which are explicitly installed on your system with Pacman-Q and then E. This is going to show us all of the packages that you've explicitly installed on your system. So it is always good to audit that. You can also show all packages with Pacman-Q without the E. And let's put this into less, so we can move through it. So obviously these are all the dependencies, not only the explicitly installed packages, but also their dependencies. This is obvious a lot, but nevertheless, it's good to get a grasp of exactly what's on your system. And we can check if a specific package is installed with, for example, we just installed UFW, the uncomplicated firewall. So we can say Pacman-Q UFW, and we might also want to see packages that came with its dependencies. So we can say Pacman QI and then UFW, and we can see that it depends on here IP tables and also Python. So not too much in that. We can also see which files that are implemented. So we can say Pacman-QL UFW. And we can see here all the files that came along when we installed UFW. If you ever see a file and you want to see which package it belongs to, you can say Pacman and then QO and say, for example, I have ZSH. So I'm going to say ZSH and we'll see what's in here. Z profile, for example. We can see that it's owned by ZSH and the version. So that would help us to understand if there was any kind of file that you weren't aware of, you could go and have a look at that. You can also check if there's been any changed files. So for example, we might say Pacman QK and then we'll say ZSH. And we see that it's got all these files, but it doesn't have any missing or changed files. We can have a look at the packages which are out of date with Pacman-QDT. And we can see that I've got 3 packages, in fact, which are currently out of date. Now, we might also install and uninstall packages over time, and we may end up with orphan packages. So the way that we would want to uninstall orphan packages, or if we wanted to uninstall something, we'd say pacman rns, and then we can say pacman -qdtq, and of course we got to run that as root. I'm going to go ahead and accept that. We also sometimes want to install things that are not available in the official Arch repositories, so we can see which packages have been installed as such with pacman q, and then here we're going to say m, and I have a handful here: auto CPU freak, brave, paru, timeshift. So I'm aware of these already, but of course just understanding how to use Pacman, and go ahead and have a look at the manual. Try to limit your system to as few packages as possible, and try and use the packages from the Arch official repositories rather than the AUR, and try and use obviously packages which are more common and more popular because they're more likely to have been audited by the open source community. This ultimately is a big undertaking to understand exactly what's going on in your system, and so therefore if we can reduce the amount of packages that you're using, all the better. If you ever suspect something is going on in your system, you want to understand it better, one of the great tools that you can use is htop. We can have a look at the CPU, the memory, and so forth. And so if that seems totally out of whack, as long as all these processes, if you see anything there which you're actually not running or you don't think should be running, that's a really good place to kind of get started with respect to debugging anything which you think is peculiar. But of course, sometimes you have to go deeper than that. And one of the tools that we can use is journal-ctl. So if we want to see all the system logs, we can say journal-ctl. And this is going to show everything that's happening on the system. Obviously, there's a lot of things that we can do. For example, you might want to follow what's going on. So journal ctl-f. Okay, and just in another session, I just restarted the SSH daemon just to see that we detected that inside the journal ctl logs. We can see all logs since the last boot. If we come in here and we say -b, and of course this is going to sometimes be a lot of information, so we can break it down. We might want to look at a specific boot. So let's say we want to look at 2 boots ago. So I'm going to say journal ctl b-3, and we can see on May 10 that there was a boot, and we might want to see just error logs. So we can say journal ctl. One last thing that we might want to do when it comes to kind of looking at system information is use this command sudo ss and then tulpn, and we can see which ports are currently open. So if any of them look a little bit suspicious, for example, here we can see that we've got Brave, and then we have Network Manager and SSHD. So if there were any other servers or any other ports that you didn't expect, you could see what's going on there. All right, you're making some really big strides with respect to the security on your system. The thing is, by default, when you install Arch Linux, you actually have to turn secure boot off. But that means that at the time of boot, the kernel and what is loaded by your bootloader, as in the operating system, could indeed be tampered with. So we want to re-enable secure boot. So let's go and do that. All right, team. So in order to get secure boot set up, we first need to boot into the BIOS, and we need to get it into setup mode. It should already be disabled because you're running Arch, and in order to install it, you had to disable it. So let's go ahead and get it into setup mode. It's going to be like this. Of course, it's going to depend on your model. On this ThinkPad, I'm simply going to hit the F1 key. That's going to get me into the BIOS. Now in here, I just need to go across to security and then down to secure boot. And in here we can see we can clear all the secure boot keys. Now this is an important step if you're not going to be dual booting. I'm going to clear all of these. And now we can see that it's been put into setup mode. If you just wanted to put it in setup mode with the Microsoft keys, you could have just done reset to setup mode. Now, you can also see that by default, secure boot is disabled. So I'm going to now go and save this with F10. All right, and we'll boot in and we will go through the secure boot setup. I'll see you back on the machine. Okay, so in order to get secure boot set up, I'm going to be using a tool called sbctl. So we can download that from the official Arch repositories with sudo pacman syu and then sbctl. Okay, so it's installed. So the first thing that we need to do is create the keys that we're going to enroll for our secure boot setup. We're going to say sudo sbctl create keys. Okay, and now we can go and say sudo sbctl status. Okay, we can see that setup mode is enabled. We've got our owner GUID set up. Secure boot is disabled and the vendor keys is none. Now, I mentioned when we were booting up that I've wiped my vendor keys, but if you want to have your vendor keys, your Microsoft keys, you can include them. The only thing is, when we do the next step, you want to pass the Microsoft flag when you're enrolling those keys. So you want to enroll your keys alongside the Microsoft keys. So I'm going to now enroll the keys. So sudo sbctl enroll keys. And you could also pass the Microsoft flag. I'm not going to, but just in case you are. Okay, so now we've got our keys enrolled. So there's a few things that we need to sign. Firstly, we're going to sign the Linux kernel. So in my case, I just have the one kernel, but if you've got additional kernels, you need to make sure that they're signed. So we're going to say sudo sbctl sign -s and then boot vm linus-linux. So this is the compressed kernel which your bootloader is going to be loading at boot time. I'm going to sign that. Okay, so we've signed the Linux kernel, the compressed Linux kernel, which the bootloader is going to reference and load. But before we can sign our bootloader EFI file, what we need to do is actually reinstall GRUB. Now, I'm assuming that you followed my guide or you've already got GRUB set up. And so I'm going to reinstall GRUB and I'm going to provide 2 additional fields so that the secure boot can work with my configuration. My configuration has an encrypted disk and I'd highly recommend that you encrypt your disk at rest. So when you install Arch, you're setting it up in a way that it's encrypted with Lux Encrypt. I'm going to reinstall GRUB. We're going to do that with sudo grub install, and the target is going to be x86_64-EFI, and the directory, EFI directory, is going to be boot. The bootloader ID is going to be grub. We're going to disable shim lock. Now, if you're intending to dual boot, you won't need this flag. Shim is for the OEM keys, which we refer to when we booted and we put it into setup mode. In my case, I cleared those keys from the system. However, if you did pass the Microsoft flag command when you enrolled your keys, then disabling shimlock may not be necessary. In my case, I'm just purely using Arch Linux. Next, we're going to have the modules, and here we're going to be using TPM. Now, finally, I'm going to pass the recheck command because I already have GRUB installed. Okay, now that we've updated our GRUB install, we need to go and remake our config. So we're going to say sudo grub mkconfig. Output is going to be at boot grub.cfg. Now we're in a position where we can sign our GRUB EFI binary. So we can do that with sudo sbctl sign -s, and we're going to point to boot EFI grub and grub x64 EFI. Next, what we can do is we can check that both of those files have been signed. So we can do that with sudo sbctl list files. Okay, so everything's set up and now we're ready to reboot the machine, go back into the BIOS and enable secure boot. Okay, so we're booting back into the BIOS and now we just need to enable secure boot. So we go across to security, down to secure boot, hit enable, save that. And this is a good moment to talk about the fact is that if you don't have a supervisor password on the machine, anyone could just log in and disable secure boot and all of the effort here would have been for nothing. So keep that in mind. I'm not going to apply a supervisor password, but it's something to think about. Also, as I mentioned, you certainly need to encrypt your disk. So here you can see that it's asking for my encryption password. Make sure that you set that up when you install Arch. Okay, so now I'll see you back on the machine for the final step. Okay, so back on our system, we've enabled secure boot, and we can see this by running the command sudo sbctl status. And we can see that we've got sbctl installed, the setup mode is disabled and secure boot is enabled. There's no vendor keys in my case, as I mentioned. Still, there are things that we could do. We could, for example, restrict access to the GRUB files, or we could make them immutable. I'm not going to cover that in this tutorial, but you can refer to my Arch Linux setup guide and link that in the description. You could also disable recovery and also disable OS Prober. These are some security considerations that will further harden your GRUB setup. However, there is one last thing that we're going to do, and that is we are going to make a password for GRUB. So the way that we're going to do that is with grub mk passwd pbk df2. Okay, so now we've got the hash that we created, and we're going to go and edit the grub d40 custom file. So we're going to say sudo nvim etc grub d40 custom. Here we're going to say set super users equals admin, and we're going to say password pbk df2 admin, and then paste the hash that we had. Now we need to update grub, and the way that we do that is with sudo grub mkconfig o, and we're going to say boot grub.cfg. Okay, it's awesome that you've made it this far. I'm very proud of you. And the thing is, if you did that, then you need to subscribe. Now, this is not intended to be exhaustive. This is the beginning of your Linux journey and hardening your system. The point is, I just don't want you to get hacked. Big part of security is about not being the lowest hanging fruit. Now, if you haven't done it already, when you install Arch, make sure you do encrypt your drive. So when your data is at rest or someone steals your device, then they can't get their hands on your sensitive information. There's a lot more that you can do. There's tons of utilities, there's containerization, there's tools like fail to ban for SSH hardening. Even further, you can use two-factor authentication, and some of this stuff we've touched on. But the point is not to do everything. The point is to give you a foundation, and that we're very much done here. So I'd like to thank you. I hope to see you back at the RUD lectures soon. Bye-bye.